Okay, today we're learning about the area of a circle and the sector area. So obviously you know what a circle is. A sector is going to be like, think of it like a piece of pie. It's a piece of the circle. So it's made, how a sector is made is you have your circle and then you have your center and a radius and another radius. When it's plural, you call them radii, like it looks like this with two eyes. It's really weird, but that's the plural of like two radiuses, but that's even weirder. So then the sector area is like the area of this pie-shaped piece. And so those are the two things we're going to learn today. So let's go ahead and let's start with a circle. So I'm going to zoom in here. So we're going to start down this left column. So area of a circle. All right, so first of all, your area of a circle is pi r squared. So that's pretty typical. It hasn't changed any. R is for the radius. Pi is obviously a number, approximately 3.14. So this says, find the area of a circle with a radius of 4. So if you know the radius, that's all you need to find the area. So you're going to do pi times the radius squared. So 4 squared is 16. So the area is 16 pi. That's your exact answer. If it says leave in terms of pi or give the exact answer, that's what you're going to put. If it wants the approximate answer, we're going to type in our calculator. We can either type in 16 times pi, or we can even do pi times 4 squared. It's the same thing. We get 50.27 centimeters squared. Okay. So here, find the area of the circle. If you look at the 11, it's indicating that the 11 is the diameter. So if 11 is the diameter, what is the radius? All right, you divide it by 2, and the radius is 5.5. So if the radius is 5.5, what is the area of the circle? All right, so we do area is pi r squared. R is 5.5 squared. So we type that in our calculator. And if you wanted the exact answer, you just have 30.25 pi, because that's 5.5 squared. But you probably want the approximate answer, so type in pi times 5.5 squared, and you get roughly 95.03. And that's centimeters squared. Area is always whatever the units are, squared. Okay. This says find the diameter of a circle. So you know the area. You're finding the diameter. The area is 96 pi centimeters squared. Well, keep in mind, we have this formula. Area equals pi r squared. The area is 96 pi. And if we solve, we're going to get the radius, but that's okay because we can use the radius to find the diameter. So first I'm going to divide by pi on both sides. So 96 pi divided by pi, the pi's cancel out. So you're left with 96 equals r squared. So now we are going to square root to get r by itself. So the square root of 96 is roughly 9.8. So that's your radius. If they want the diameter, remember the diameter is twice the radius. So if we times that by 2, then we're going to get roughly 19.6. And if the area was centimeters squared, then the diameter is just regular centimeters. Okay. What is the area of a semicircle whose diameter is 8 meters? All right, well, first of all, the diameter is 8, so what is the radius? All right, the radius is 4. Now, if you think about that circle, the radius is 4, so we can find the area of the circle as pi times radius squared. So that's 16 pi. Okay, that's the area. I'm just going to leave it in terms of pi just so it's exact and I'm not rounding. What I don't like to do is round the answer and then use that rounded answer to find another answer, because that's just making your rounding get like more inaccurate, more off every time. So here's your area for the whole circle. So if you want the semicircle is half of the circle. Okay, so you're going to take the 16 pi and you're going to do half of it because you just want the semicircle. So that's 8 pi. Or if you want it as a decimal, then we type in our calculator 8 times pi, and we get roughly 25.13 meters squared. And that would be our solution. Okay, these problems, when they're shaded, it really helps to visualize it in terms of like having two shapes that you cut out. So right here, it wants the area between the two concentric circles, like the shaded region. So remember, concentric circles are circles that are in the same plane and share a center. So they're kind of stacked on top of each other. So to find that shaded donut, we need to take the bigger circle and cut out the middle circle. And what we will be left with is kind of this donut that we're seeing right there. Bigger circle, cutting out the middle. And when you cut something out, that's like subtracting. So the bigger circle, the radius is 5. The smaller circle, the radius is 3. So the big circle is pi r squared. That's 25 pi. Minus the smaller circle is pi r squared. 3 squared is 9, so it's 9 pi. 25 pi minus 9 pi, you can just subtract 25 minus 9. Think of it kind of like a variable, like 25x minus 9x. You just subtract. So you can do that with pi also. So you get 16 pi, and that would be your, and that's in inches squared. That would be your area of the donut. That is the like exact area. If you want it approximated, remember, of course, you just type it in your calculator. And so roughly 50.27 inches squared, or squared inches. Okay, so area of a sector. So the sector of a circle is a region with two radii in their intercepted arc. So it's the shaded end pi piece. So the area of a sector is really easy. It's very similar to the area, the length of an arc length, where you take the degrees over 360. So degrees divided by 360. And then because it's an area, you take a piece of the area formula. That's why you use pi r squared right here. Versus on the formula we used for the arc length, it was a piece of the circumference. So we did degree over 360. And then we used the circumference, 2 pi r. That's the difference. So since this is an area, degree over 360 times the area of a circle, which is pi r squared. Okay, so this is actually pretty easy. So it says, I'm just going to write our formula for the first time. All right, so find the area of the sector if it intercepts an arc with a major of 40 degrees. So this arc is 40 degrees. Sorry, I didn't write that clearly. If this arc is 40 degrees, then this angle is also 40 degrees. So the degree is 40 degrees over 360 times pi. The radius is 8 squared. Okay, so I'm going to type that in my calculator, and honestly, when I type it in, it just likes 40 divided by 360 times pi parentheses 8 squared. That's how I do it. You can also use the fraction key. So let's see what we got here. Times pi times 8 squared. Okay, I got 22.34, and we're in centimeters, but it's an area, so centimeters squared. Okay, go ahead and try this one. All right, so we do 66 over 360 times pi, radius is 15 squared. So we just type that in our calculator. Okay, so I ended up with approximately 129.59, and this is, it doesn't say what units, so I'm just going to put units squared. All right, this one is a little different because it says find the measure of the central angle. So they want the angle of a sector if the area of the sector is 12 pi centimeters squared and the radius is 6. So basically, we don't know the degrees. We know the radius is 6, and we know the actual area is 12 pi. So what I'm going to do is where I wrote degrees, instead, I'm just going to call that x. Let's just call it something else. Let's put an x there, or d for degrees, if that helps you. So what I would do is think of this instead of 6 squared as 36. You have x over 360 times 36 pi. Okay. So, what I think I'm going to do to start with, there's several different ways you could do this, but I'm going to go ahead and because it's multiplying over here, like all this x over 360 is multiplying with 36 pi, we can rearrange because in multiplying, you can multiply in any order. So I'm going to switch the x. It's still the same thing. It just gets x by itself. And that's because multiplying is commutative. The order doesn't matter. So now to get x by itself, I need to move this fraction, 36 pi over 360. So how you move a fraction is you multiply by the reciprocal. It's that whole flip and multiply thing. And remember, the reason that this works is because you have 360 over 360, that makes 1. 36 pi over 36 pi makes 1. Okay, so when I type this, when I think of this, I guess, is you can type it in your calculator and honestly it'll come out fine, or you can simplify it. So like personally, I see this as, okay, the pi's are going to cancel out because there's a pi on top and a pi on bottom. 12 over 36 is going to be 1/3. So right now we have 360 over 3, and that makes 120. So the degree is 120 degrees. So there's a few different ways we could do that. So like the 12 pi times 360 over 36 pi. You could also cancel out the pi's and just type in 12 times 360 divided by 36. You can type it all in your calculator with the pi's. It'll work out fine either way. Okay, last but not least, find the area of the circle. Okay, this one's tricky. If the area of a 40-degree sector, okay, we know our degrees, is 34 meters squared. Okay, so the area of the sector all right, so what I think we can do is I think we can do degrees over 360 times pi r squared equals the area of the sector. Now we're going to solve for r, and once we know our radius, which is r, keep in mind all we're finding here is like a little pi piece. So once we know our radius, then we can go back and find the area of the entire circle. Okay, so what I'm going to do first is I'm going to multiply by 360 over 40 on both sides. All right, and so that gets me, I'm going to take 34 times 360 divided by 40, and that gets me pi r squared equals 306. Okay, so then divide by pi, and I get 306 divided by pi is 97.4, it's a really long number, 40282517, and then square root it to get r by itself. I'm not going to retype it in my calculator. I'm going to square root and copy in the answer. I don't want to round it off because I'm continuing to use a rounded number. That'll make me like way more rounded than I should be. So I get 9.87. So now to find the area of a circle, that was pi r squared. So if we do pi times 9.87 squared, all right, then we get 306. Now, do you notice anything? I was kind of showing you the far way to do this because if you don't notice this rule, then you're going to be like, how do I do this? And you can find the radius. Another way you could do this is, think about this. I told you at the beginning, it was degrees over 360 times the area of the circle, and that gets you the area of the sector. And so, when you did this spot right here, when you moved the 360 over 40 on both sides, you were left with this, pi r squared. That's literally your area of your circle. And so you could have stopped right there and said, hey, this circle is 306. But just in case you don't see that, I gave you kind of the long way that will work every time. But I'm hoping that we'll get stronger and see that as we go, just to make ourselves more accurate, but also make it quicker and easier for us.